In this video, we're just getting some practice with the Ampere's law right-hand rule. So what we're trying to figure out here is the direction of magnetic field generated by a current. That's in part A, and then we reverse the process and we look at a magnetic field generated by a current in part B, and we have to infer the direction of the current itself. So the right-hand rule for this is that you put your thumb in the direction of the current flow, and then the fingers of your right hand wrap around in the direction of the magnetic field that results. So in part A, I just put my thumb in the direction of the current, and this current points into the page. That's what the X means. So it looks something like this. I wrap the fingers of my right hand around in their natural direction, and I find the magnetic field is looping clockwise around this current, and it looks something like this. Now, to make the picture even better, I probably should have made the magnetic field lines get farther and farther apart, because that magnetic field is actually dropping off like 1 over R in its strength. It gets weaker the farther you get from the wire. In part B, we have a current loop, and inside that current loop, we observe a magnetic field pointing into the page. And so I have to figure out which way does the current have to point to make this happen inside of the loop. And there's only 2 ways we could go with this. The current could be clockwise or it could be counterclockwise. And visualizing those 2 options, we can come up with the right direction pretty quickly. I'm going to go ahead and start with the right answer here and then explain why it's the right answer. And my claim here is that the current must be flowing clockwise. To see why this is true, stick your thumb in the direction of the current, wrap the fingers of your right hand around, and I can see that my fingers would be diving into the page within the interior of the loop. This also means my fingers are returning out of the page outside of the loop, and that's something that wasn't shown in the diagram. But outside of this loop, we should have magnetic field lines pointing out of the page. Just to be extra sure, we apply the right-hand rule to a different spot on the loop, and I stick my thumb in the direction of the current, wrap my fingers around, and again, my fingers dive into the page inside the loop, and they come back out of the page when I'm outside of the loop. So we've got our current in the right direction. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.